Carbon Fiber by Pamela McPherson. Introduction. Carbon, a fiber made of at least 96% pure carbon. Raw materials known as precursors are drawn into long strands. Creating carbon fiber involves both chemical and mechanical processes. Raw materials known as precursors are drawn into long strands and then heated to high temperatures in an anaerobic, oxygen-free environment. Rather than burning, the extreme heat causes the fiber atoms to vibrate so violently that almost all non-carbon atoms are expelled. The origin or source of carbon fibers are called precursors. About 90% of the carbon fibers produced are made from polyacrylonitrile, or PAN. The remaining 10% are made from rayon or petroleum pitch. These materials are organic polymers characterized by long strings of molecules bound together by carbon atoms. The exact composition of each precursor varies from one company to another and is generally considered a trade secret. This is a series of anaerobic, oxygen-free ovens. The white precursor fiber is on the bottom. As the heat of each oven reaches progressively higher temperatures, the fiber color changes to gold, copper, brown, and finally black. During the manufacturing process, a variety of gases and liquids are used. Some of these materials are designed to react with the fiber to achieve a special effect. Other materials are designed not to react or to prevent certain reactions with the fiber. This represents the process from a precursor fiber to finished carbon fiber. The bands of fibers travel through a series of anaerobic ovens where no oxygen can get in and cause the fibers to burn instead of carbonize. Surface treatments and sizing prepare the fiber to bond to materials that will strengthen the final product. The pan process is outlined. You can follow it here. And then the pitch process. This is spun and then drawn through. With the pan process, it's pre-spun, spooled, and then it goes through the process. How the fiber is made. The following 5 segments are typical in the pan process for the manufacture of carbon fiber. Spinning. Pan is mixed with other ingredients and spun into fibers, which are then washed and stretched. Stabilizing. The fibers undergo chemical alteration to stabilize bonding. Carbonization. Stabilized fibers are heated to a very high temperature, forming tightly bonded carbon crystals. Treating the surface. The surface of the fibers is oxidized to improve the bonding properties. Sizing. Fibers are coated and wound onto bobbins, which are loaded onto spinning machines that twist the fibers into different size yarns. Rather than being woven into fabrics, fibers can also be formed into composite materials using heat, pressure, or a vacuum to bind fibers together with a plastic polymer. After the carbonization process is complete, the remaining fiber is made up of long, tightly interlocked carbon atom chains, with few or no non-carbon atoms remaining. These fibers are subsequently woven into fabric or combined with other materials that are then filament wound or molded into the desired shapes and sizes. This is one of the spools of the fiber, and you can see how many little fibers, how many little strands it takes to make one of these pieces of tape, which would be woven into fabric like this. Ingredients in carbon fiber. Carbon fiber is made from organic polymers which consist of long strings of molecules held together by carbon atoms. Most carbon fibers, about 90%, are made from the polyacrylonitrile pan process. A small amount, about 10%, are manufactured from rayon or the petroleum pitch process. Whatever the source, when finished, carbon fibers are made up of at least 96% pure carbon. Properties of carbon fiber. High strength to weight ratio, also known as specific strength, very rigid, corrosion resistant, and chemically stable. Electrically conductive, fatigue resistant, good tensile strength, fire resistant, non-flammable. Thermal conductivity of carbon fiber. Special types of carbon fiber have been specifically designed for high or low thermal conductivity. There are also efforts to enhance this feature. Low coefficient of thermal expansion. That makes it useful in telescopes and other optical machinery. Non-poisonous, biologically inert, X-ray permeable. These properties make carbon fiber useful in medical equipment. Relatively expensive and brittle. Carbon fibers, you see them here. After they've been placed in bobbins, they're threaded through machines and they're spun into fibers or tapes. Common uses of carbon fiber, high-end automotive components, bicycle frames, fishing rods, shoe soles, baseball bats, protective cases for laptops and iPhones. More exotic uses can be found in the aeronautics and aerospace industries, oil and gas industry, unmanned aerial vehicles, satellites, Formula One race cars. Some would argue, though, that the possibilities for carbon fiber are limited only by demand and the manufacturer's imagination. Now it's even common to find carbon fiber in musical instruments, furniture, art, structural elements of buildings, bridges, wind turbine blades. Some of the trade names of carbon fiber are Hextow, Pyrophil, Thornell, Thermographs, Panex, and Pyron. These are some of the uses that you may see being fabricated with carbon fibers. You can see the carbon here in this fender, and part of the wheel is fiber. The spoiler is fiber, carbon fiber. Carbon fiber bike. You can see the weave in the helmet. This would have been molded and pressurized so that it would turn out to be like this. And even these artificial limbs, we see those quite often now. It's quite a blessing, actually. Thank you. Here are my references for images and my works cited. Thank you for watching.